In this module, you'll learn the basics of PowerShell scripting. Scripting is about automation. It's about storing steps that you do often in a file. By running files that contain your scripts, you can save time and reuse existing solutions. You can then spend that time on something more valuable. In this module, you'll learn some helpful constructs of the PowerShell language and how you can use them to create and run scripts. Learning objectives: after completing this module, you will be able to write and run scripts. Use variables and parameters to make your scripts flexible. Apply flow control logic to make intelligent decisions. Add robustness to your scripts by adding error management. PowerShell scripting is the process of writing a set of statements in the PowerShell language and storing those statements in a text file. Why would you do that? After you use PowerShell for a while, you find yourself repeating certain tasks, like producing log reports or managing users. When you've repeated something frequently, it's probably a good idea to automate it, to store it in such a way that makes it easy to reuse. The steps to automate your task usually include calls to commands, functions, variables, and more. To store these steps, you'll create a file that ends in .ps1 and save it. You'll then have a script you can run. Before you start learning to script, let's get an overview of the features of the PowerShell scripting language. Variables. You can use variables to store values. You can also use variables as arguments to commands. Functions. A function is a named list of statements. Functions produce an output that display in the console. You can also use functions as input for other commands. Flow control. Flow control is how you control various execution paths by using constructs like if, else if, and else. Loops. Loops are constructs that let you operate on arrays, inspect each item, and do some kind of operation on each item. But loops are about more than array iteration. You can also conditionally continue to run a loop by using do-while loops. For more information, see about do. Error handling. It's important to write scripts that are robust and can handle various types of errors. You'll need to know the difference between terminating and non-terminating errors. You'll use constructs like try and catch. We'll cover this topic in the last conceptual unit of this module. Expressions. You'll frequently use expressions in PowerShell scripts. For example, to create custom columns or custom sort expressions. Expressions are representations of values in PowerShell syntax. .NET and .NET Core integration. PowerShell provides powerful integration with .NET and .NET Core. This integration is beyond the scope of this module. Run a script. You need to be aware that some scripts aren't safe. If you find a script on the internet, you probably shouldn't run it on your computer unless you understand exactly what it does. Even with scripts you consider safe, there might be a risk. For example, imagine a script that cleans things up in a test environment. That script might be harmful in a production environment. You need to understand what a script does, whether it was written by you or by a colleague or if you got it from the internet. PowerShell attempts to protect you from doing things unintentionally in two main ways: requirement to run scripts by using a full path or relative path. When you run a script, you always need to provide the script's path. Providing the path helps you to know exactly what you're running. For example, there could be commands and aliases on your computer you don't intend to run, but that have the same name as your script. Including the path provides an extra check to ensure you run exactly what you want to run. Execution policy. An execution policy is a safety feature. Like requiring the path of a script, a policy can stop you from doing unintentional things. You can set the policy on various levels, like the local computer, current user, or particular session. You can also use a group policy setting to set execution policies for computers and users. These two mechanisms don't stop you from opening a file, copying its contents, placing the contents in a text file, and running the file. they also don't stop you from running the code via the console. These mechanisms help to stop you from doing something unintentional. They aren't a security system. To create and run a script, create some PowerShell statements like the following and save them in a file that ends with .ps1. Execution policy. You can manage execution policy using these commands. Get execution policy. This command returns the current execution policy. On Linux and Mac OS, the value returned is unrestricted. For these operating systems, you can't change the value. That limitation doesn't make Linux or Mac any less safe. Remember, an execution policy is a safety feature, not a security mechanism. Set execution policy. If you're using a Windows computer, you can use this command to change the value of an execution policy. It takes an execution policy parameter. There are a few possible values. It's a good idea to use default as the value. That value sets the policy to restricted on Windows clients and remote signed on Windows Server. Restricted means you can't run scripts. You can run only commands, which makes sense on a client. Remote signed means that scripts written on the local computer can run. Scripts downloaded from the internet need to be signed by a digital signature from a trusted publisher. When you output text via write host or write output, you can use single or double quotation marks. Your choice depends on whether you want to interpolate the values. There are three mechanisms you should know about. Single quotation marks. Single quotation marks specify literals, what you write is what you get. Here's an example. If you want to interpolate, to get the value of $pi interpreted and printed, you need to use double quotation marks. Double quotation marks. When you use double quotation marks, variables in strings are interpolated. There are two things going on here. The backtick lets you escape what would be an interpolation of the first instance of $pi. In the second instance, the value is interpolated and is written out. $. You can also write an expression within double quotation marks. To do that, use the $construct. One way to use this construct is to interpolate properties of objects. Here's an example. Scope is how PowerShell defines where constructs like variables, aliases, and functions can be read and changed. When you're learning to write scripts, you need to know what you have access to, what you can change, and where you can change it. If you don't understand how scope works, your code might not work as you expect it to. Types of scope. Let's talk about the various scopes. Global scope. When you create constructs like variables in this scope, they continue to exist after your session ends. Anything that's present when you start a new PowerShell session can be said to be in this scope. Script scope. When you run a script file, a script scope is created. For example, a variable or a function defined in the file is in the script scope. It will no longer exist after the file is finished running. For example, you can create a variable in the script file and target the global scope. But you need to explicitly define that scope by prepending the variable with the global keyword. Local scope. The local scope is the current scope, and can be the global scope or any other scope. Scope rules. Scope rules help you understand what values are visible at a given point. They also help you understand how to change a value. Scopes can nest. A scope can have a parent scope. A parent scope is an outer scope, outside of the scope you're in. For example, a local scope can have the global scope as a parent scope. Conversely, a scope can have a nested scope, also known as a child scope. Items are visible in the current and child scopes. An item, like a variable or a function, is visible in the scope in which it's created. By default, it's also visible in any child scopes. You can change that behavior by making the item private within the scope. Here's an example that uses a variable defined in the console. If you have a script.ps1 file that contains the following content, it will print hi when the script runs. You can see that the variable $test is visible in both the local scope and its child scope, in this case, the script scope. Items can be changed only in the created scope. By default, you can change an item only in the scope in which it was created. You can change this behavior by explicitly specifying a different scope. Profiles. A profile is a script that runs when PowerShell starts. You can use a profile to customize your environment to, for example, change background colors and errors and do other types of customizations. PowerShell will apply these changes to each new session you start. Profile types. PowerShell supports several profile files. You can apply them at various levels, as you see here. There are two variables here, $shum and $home. $shum points to the installation directory for PowerShell. $home is the current user's home directory. Other programs also support profiles, like Visual Studio Code. Create a profile. When you first install PowerShell, there are no profiles, but there is a $profile variable. It's an object that points to the path where each profile to apply should be placed. To create a profile, decide the level on which you want to create the profile. You can run $profile select object * to see the profile types and the paths associated with them. Select a profile type and create a text file at its location by using a command like this one, new item path $profile.current user current host. Add your customizations to the text file and save it. The next time you start a session, your changes will be applied. In this unit, you'll use Azure Cloud Shell on the right side of your screen as your Linux terminal. Azure Cloud Shell is a shell you can access through the Azure portal or at HTTP URL. You don't have to install anything on your computer to use it. First, you'll learn how to set up a profile so you can customize your working environment the way you want it. You'll then write some basic scripts and get a feeling for interpolation and scope. Set up a profile. A profile is a script that runs when you start a new session. Having a customized environment can make you more productive. Enter PWSH in a terminal window to start a PowerShell session. Create and run a script. Now that you have a profile set up, it's time to create and run a script. Ensure you have an existing PowerShell session running. In the console window, enter this code. After you've created a few scripts, you might notice your scripts aren't flexible. Going into your scripts to change them isn't efficient. There's a better way to handle changes: use parameters. Using parameters makes your scripts flexible, because it allows users to select options or send input to the scripts. You won't need to change your scripts as frequently, because in some cases you'll just need to change a parameter value. Methods, functions, and scripts all accept parameters. Declare and use a parameter. To declare a parameter, you need to use the keyword param with an open and close parenthesis. Inside the parentheses, you define your parameters, separating them with commas. A typical parameter declaration might look like this. The script has a $path parameter that's later used in the script to create a file. The script is now more flexible. Use the parameter to call a script with a parameter. You need to provide a name and a value. Assume the above script is called createFile.ps1. You could call it like this. Because you used a parameter, you don't need to change the script file when you want to call the file something else. This particular script might not benefit much from using a parameter, because it only calls new item. As soon as your script is a few lines long, using the parameter will pay off. Improve your parameters. When you first create a script that uses parameters, you might remember exactly what the parameters are for and what values are reasonable for them. As time passes, you might forget those details. You might also want to give a script to a colleague. The solution in these cases is to be explicit, which makes your scripts easy to use. You want a script to fail early if it passes unreasonable parameter values. Here are some things to consider when you define parameters. Is it mandatory? Is the parameter optional or required? What values are allowed? What values are reasonable? Does it accept more than one type of value? Does the parameter accept any type of value, like string, boolean, integer, and object? Can the parameter rely on a default? Can you omit the value altogether and rely on a default value instead? Can you further improve the user experience? Can you be even clearer to your user by providing a help message? Select an approach. All parameters are optional by default. That default might work in some cases, but sometimes you need your user to provide parameter values, and the values need to be reasonable ones. If the user doesn't provide a value to a parameter, the script should quit or tell the user how to fix the problem. The worst scenario is for the script to continue and do things you don't want it to do. There are a couple of approaches you can use to make your script safer. You can write custom code to inspect the parameter value. Or, you can use decorators that do roughly the same thing. Let's look at both approaches. Use if/else. The if/else construct allows you to check the value of a parameter and then decide what to do. Here's an example. The script will run write error if you don't provide a value for $path. Use the parameter decorator. A better way, which requires less typing, is to use the parameter decorator. You can improve this decorator by providing a help message users will see when they run the script. Assign a type. If you assign a type to a parameter, you can say, for example, that the parameter accepts only strings, not booleans. That way, the user knows what to expect. You can assign a type to a parameter by preceding it with the type enclosed in brackets. These three approaches aren't mutually exclusive. You can combine them to make your script safer. In this unit, you'll use Azure Cloud Shell on the right side of your screen as your Linux terminal. Azure Cloud Shell is a shell you can access through. Create a backup script. A common task is to create a backup. A backup is usually a compressed file that stores all the files belonging to, for example, an app. When you installed PowerShell, you got the controlled compress archive, which can help you complete this task. In your Cloud Shell terminal, run these bash commands. The script invokes compress archive and uses three parameters. Path is the directory of the files that you want to compress. Compression level specifies how much to compress the files. Destination path is the path to the resulting compressed file. Add parameters to your script. If you add parameters to your script, users can provide values when it runs. You add parameters to your backup script to enable configuration of the locations of the source files and the resulting zip file. Add the following code to the top of the backup.ps1 file. You've added two parameters to your script, $path and $destination path. You've also provided default values so users don't need to provide the values. Users can override the default values if they need to. You need to adjust the script to use these parameters. You'll do so next. Change the code in the file to use the parameters, then save the file. Backup.ps1 should now look like this. Renaming the app directory simulates the fact that not all directories you'll need to backup will be called app. You can no longer rely on the default value for $path. You'll need to provide a value via the console when you run the script. Remove your backup file, replacing with the current date. You're removing this file to make sure you get a message stating that your $path value doesn't exist. Otherwise, you'd get a message about the zip file already existing, and the problem we're trying to fix would be hidden. Run your script without providing parameters. The script will use default values for the parameters. The script notifies you that it can't find the directory /app. Now it's time to provide a value to the $path parameter and see the benefit of adding parameters to your script. Test your script by running it. You can now use parameters if the directory you want to backup isn't called /app or if you want to put the compressed file somewhere other than the current directory. Congratulations! You created a backup script that you can use whenever you want to create a backup for an app directory or any other important directory. You then identified parts of your script that might need to change often and replaced static values with parameter values. That way, you most likely won't need to change the script itself when your requirements change, for example, if the name of the app changes or you need to change the destination path. Flow control completed 100 XP 4 minutes. Flow control refers to how your code runs in your console or script. It describes the flow the code follows and how you control that flow. There are various constructs available to help you control the flow. The code can run all the statements, or only some of them. It can also repeat certain statements until it meets a certain condition. Let's examine these flow control constructs to see what they can do. Sanitize input. If you use parameters in a script, you need to ensure your parameters hold reasonable values so your script works as intended. Writing code to manage this process is called sanitizing input. Control execution flow. The previous technique ensures you get reasonable and correct input data. This technique is more about deciding how to run code. The value set can determine which group of statements runs. Iterate over data. Sometimes your data takes the form of an array, which is a data structure that contains many items. For such data, you might need to examine each item and perform an operation for each one. Many constructs in PowerShell can help you with that process. Iterating over arrays is outside the scope of this module. There are many constructs to handle flow control in PowerShell. We can't name them all, but we'll talk about some important ones that you're likely to encounter in scripts that you read or write. Manage input and execution flow by using if, else if, and else. You can use an if construct to determine if an expression is true or false. Depending on that determination, you might run the statement defined by the if construct. The syntax for if looks like this. Operators. PowerShell has two built-in parameters to determine if an expression is true or false. $true indicates that an expression is true. $false indicates that an expression is false. You can use operators to determine if an expression is true or false. There are a few operators. The basic idea is usually to determine if something on the left side of the operator matches something on the right side, given the operator's condition. An operator can express conditions like whether something is equal to something else, larger than something else, or matches a regular expression. Here's an example of using an operator. The LA operator determines if the value on the left side of the operator is less than or equal to the value on the right side. Because we put the else next to the ending brace for the if, we created a joined construct that works as one. If you run this code in the console, you'll see that is positive prints. That's because if evaluates to false, but else evaluates to true. So else prints its statement. If and else work great to cover all the paths code can take. Else if is another construct that can be helpful. Else if is meant to be used with if. It says the expression in this construct will be evaluated if the preceding if statement evaluates to false. Like if, else if can take an expression, so it helps to think of else if as a secondary if. Here's an example that uses else if. It's possible to write this code in a more compact way, but this way does show the use of else if. It shows how if is evaluated first, then else if, and then else. When you write scripts, they might work as intended as long as you type in reasonable values. But if time passes or someone else runs the script, it's likely that someone will enter an unintended value or that some other precondition won't be met. To avoid situations like this, you should sanitize your input, that is, you should add logic to your script to ensure it quits early if something is wrong and continues to run only if everything is fine. Run the following commands only if you haven't completed any of the previous exercises in this module. We're assuming you've completed the previous exercises. If you haven't done so, you need a few files. You've been working with a backup script so far, and you've been adding parameters to it. You can make your script even safer to use by adding checks that ensure the script only continues if it's provided reasonable parameter inputs. Let's look at the current script. If you completed the previous exercise, you should have a file called backup.ps1. If not, create the file and open it in. As you know, the script will stop responding if $path points to a directory that doesn't exist. Use an existing PowerShell shell if you have one running. Otherwise, start one by typing pwsh in a terminal. You've added a test that checks if $path exists. If it doesn't, you stop the script. You also explain to users what went wrong so they can fix the problem. Ensure the script works as intended by running it. If you run the script again, it will stop responding. It will notify you that the zip file already exists. Let's fix that problem. We'll add code to ensure the backup is created only if no other backup zip file from the current day exists. Replace the code in the file with this code, then save the file. You did two things here. First, you created a new variable, $destination file. This variable makes it easy to check if the path already exists. Secondly, you added logic that says create the zip file only if the file doesn't already exist. This code implements that logic. Congratulations! You've made your script a little safer. Note that it's still possible to provide problematic input to $destination path, for example. The point of this exercise is to show how to add checks. Depending on the environment in which the script will run, you might want fewer or more checks. You might even want written tests, it all depends on the context. Error handling completed 100 XP 6 minutes so far. You've seen how adding parameters and flow control constructs can make your scripts flexible and safer to use. But sometimes, you'll get errors in your scripts. You need a way to handle those errors. Here are some factors to consider: how to handle the error. Sometimes you get errors you can recover from, and sometimes it's better to stop the script. It's important to think about the kinds of errors that can happen and how to best manage them. How severe the error is. There are various kinds of error messages. Some are more like warnings to the user that something isn't okay. Some are more severe, and the user really needs to pay attention. Your error handling approach depends on the type of error. The approach could be anything from presenting a message to raising the severity level and potentially stopping the script. Errors handled or function, for example, might generate many types of errors. We recommend that you write code to manage each type of error that might occur, and that you manage them appropriately given the type. For example, say you're trying to write to a file. You might get various types of errors depending on what's wrong. If you're not allowed to write to the file, you might get one type of error. If the file doesn't exist, you might get another type of error, and so on. There are two types of errors you can get when you run PowerShell: terminating error. An error of this type will stop execution on the row where the error occurred. You can handle this kind of error using either try catch or trap. If the error isn't handled, the script will quit at that point and no statements will run. The trap construct is outside the scope of this module. If you're interested, see about trap. Non-terminating error. This type of error will notify the user that something is wrong, but the script will continue. You can upgrade this type of error to a terminating error. Managing errors by using try/catch/. Finally, you can think of a terminating error as an unexpected error. These errors are severe. When you deal with one, you should consider what type of error it is and what to do about it. There are three related constructs that can help you manage this type of error. Try. You'll use a try block to encapsulate one or more statements. You'll place the code that you want to run, for example, code that writes to a data source, inside braces. A try must have at least one catch or finally block. Here's how it looks. Catch. You'll use this keyword to catch or manage an error when it occurs. You'll then inspect the exception object to understand what type of error occurred, where it occurred, and whether the script can recover. A catch follows immediately after a try. You can include more than one catch, one for each type of error, if you want. Here's an example. The script tries to run a command that does some I/O work. The first catch catches a specific type of error, system.io.io exception. The last catch catches anything that's not a system.io.io exception. Finally, the statements in this block will run regardless of whether anything goes wrong. You probably won't use this block much, but it can be useful for cleaning up resources, for example. To use it, add it as the last block. Inspecting errors. We've talked about exception objects in the context of catching errors. You can use these objects to inspect what went wrong and take appropriate measures. An exception object contains a message. The message tells you in a few words what went wrong. The stack trace. The stack trace tells you which statements ran before the error. Imagine you have a call to function A, followed by B, followed by C. The script stops responding at C. The stack trace will show that chain of calls. The offending row. The exception object also tells you which row the script was running when the error occurred. This information can help you debug your code. So how do you inspect an exception object? There's a built-in variable, $_, that has an exception property. To get the error message, for example, you would use $_.exception.message. In code, it might look like this. Raising errors. In some situations, you might want to cause an error, non-terminating errors. For this type of error, PowerShell just notifies you that something went wrong, by using the right error conduct, for example. The script continues to run. That might not be the behavior you want. To raise the severity of the error, you can use a parameter like error action to cause an error that can be caught with try/catch, like so. By using the error action parameter and the value stop, you can cause an error that try/catch can catch. Business rules. You might have a situation where the code doesn't actually stop responding, but you want it to for business reasons. Imagine you're sanitizing input and you check whether a parameter is a path. A business requirement might specify only certain paths are allowed, or the path needs to look a certain way. If the checks fail, it makes sense to throw an error. In a situation like this, you can use a throw block. In general, don't use throw for parameter validation. Use validation attributes instead. If you can't make your code work with these attributes, a throw might be okay. In this unit, you'll use Azure Cloud Shell on the right side of your screen as your Linux terminal. Azure Cloud Shell is a shell you can access through the Azure portal or at HTTP URL. You don't have to install anything on your computer to use it. In this exercise, you'll use a try/catch block to ensure the script stops responding early if a certain condition isn't met. You'll again work with your backup script. Say you've noticed that you sometimes specify an erroneous path, which causes backup of files that shouldn't be backed up. You decide to add some error management. Run the following commands only if you haven't completed any of the previous exercises in this module. We're assuming you've completed the previous exercises. If you haven't done so, you need a few files. Open backup.ps1. In the param section, add a comma after the last parameter, and then add the following parameter. You've added a switch parameter. If this parameter is present when the script is invoked, you perform the check on the content. After that, you can determine if a backup file should be created. Under the param section, add this code, then save the file. The preceding code first checks if the parameter $path is web app is provided at runtime. If it is, the code continues to get a list of file extensions from the directory specified by $path. In our case, if you run that part of the code on the web app directory, the following code will print a list of items. In the full statement, we're using the match operator. The match operator expects a regular expression pattern. In this case, the expression states do any of the file extensions match.html, .js, or .css. The result of the statement is saved to the variable $contains application files. Then the if block checks whether the $contains application files variable is true or false. At this point, the code can take two paths. If the source directory is for a web app, the script writes out source files look good, continuing. If the source directory isn't for a web app, the script throws an error that states not a web app. The error is caught in a catch block. The script stops, and you rethrow the error with an improved error message. Test the script by providing the switch $path is web app. Before you run the script, make sure there are no .zip files present. They might have been created when you completed previous exercises in this module. Use remove item *zip to remove them. In the PowerShell shell, run the script again, but this time change the path value to point to ./Python app. The output indicates that the check failed. It should have, because there are no files in the directory that have an .html, .js, or .css extension. Your code raised an exception that was caught by your catch block, and the script stopped early. Congratulations! You've implemented a business requirement. In this module, you learned how you can use PowerShell to automate tasks by writing and running scripts. You went on to improve your scripts by using variables and parameters to make the scripts more flexible. You then learned about flow control, and how you can use it to control how a script is run. You implemented some checks to sanitize input to ensure the script will exit early if certain conditions aren't met. You also added checks to ensure the script carries out its task, backing up files, only if there's no pre-existing backup file. Finally, you were introduced to error handling. You learned how to differentiate between non-terminating and terminating errors and how to manage both. You should now have a good understanding of how to write and run scripts. You should also be able to use various PowerShell constructs to improve a script's flexibility and robustness.